Hi, everybody. Today we are going to start talking about Chapter 4 in our textbook. And the topic of Chapter 4 is equivalent circuits, or basically methods for analyzing circuits that don't necessarily involve doing 10,000 simultaneous linear equations. So far, we have some really powerful tools for analyzing circuits. And the heaviest hitters for us are um, Kirchhoff's voltage law, Kirchhoff's current law, and of course, Ohm's law. And so in chapter 4, when we have more complicated circuits, instead of applying those laws over and over and over again, Chapter 4 suggests some very common methods of simplifying circuits. One is called, one is called the node voltage method, and the other is called the mesh current method. So in addition to these, there are some other extremely useful, depending on an application, types of analysis techniques. One is called the super mesh, which is based on the mesh current method. And then we have the Thevenin and the Norton equivalents, as well as superposition. So all of these are ways of taking complicated circuits and describing them or simplifying them to equivalent circuits that are easier to analyze from the point of view of having fewer simultaneous linear equations to solve. So it's my opinion that all of these methods are important and that you need to familiarize yourself with each of them, and that you also are able to understand when one would be chosen over another. However, the need to do these methods has become less imperative since we have developed the technology to solve simultaneous linear equations more efficiently. Because in the past, SLEs were extremely time consuming, and a lot of techniques were developed in order to learn how to solve simultaneous linear equations, but it could just take a very long time and was was very rife with the possibility of making arithmetic and other mathematical errors. So for now, I've decided to sort of break this up a little bit differently. The first thing that you will need to know are the terms for describing circuits. And so this chart tells you some ideas that you need to be very familiar with so that when these are presented in the material, that you know exactly what is being talked about. So in a scientific and technical sense, please become familiar with the ideas of nodes, essential nodes, paths, branches, essential branches, loops, meshes, and planar circuits. Also non-planar circuits, but that becomes what is not a planar circuit is a non-planar circuit. Okay, so additionally, the textbook provides 8 PowerPoints for this chapter, each of which describes one of these methods or discusses a comparison between 2 of the methods. So as I was working through this material, it occurred to me that there was probably a more efficient way for you to learn these ideas, keeping in mind that all of them accomplish the same goal for different types of circuits. And that goal is to solve the circuit more easily by employing a technique that is more sophisticated than just solving many simultaneous linear equations together. So what I've done is I have found several videos that are all about 10 minutes long, that I encourage you as you go through the PowerPoints and the textbook to watch these videos as well. So we have the node voltage method, the mesh current method, the super mesh method, the Thevenin equivalent method, Norton's theorem a technique, which is also an equivalent method, and the superposition theorem technique. So if you watch each of these, you will have a good background, not only for understanding how it works and under what circumstances it works, but for actually working problems. So for that reason, I strongly recommend that you watch these videos. The next piece is this homework is not due until February 19th, so it's still a couple of weeks out. But this material is very complicated and the homework is fairly intense. So what you'll see is I've broken down the chapter into the 13 sections, and I've assigned problems from each section except section 11, because I have assigned 2 problems from section 10 that cover 2 of the topics pretty well. And then section 12 and 13 also each have 1 problem. So when you've completed this homework, I think you will have a very good understanding of each of these methods and why it becomes important to use equivalent circuits when you are doing this kind of work. You'll also have a lot of tools in your tool bag for specific techniques to solve complicated circuits, which is the entire point of chapter 4. So if you will just take in mind that you can use these techniques under certain circumstances, that the videos, the PowerPoints, and the textbook will explain those things to you, and then rely on me as a resource when that level of understanding fails you. I feel like this is the best way to break up this huge chapter. The other thing is to remember that these are techniques. There is nothing new in terms of the theory introduced here. These are methods. So it's really a nuts and bolts kind of chapter. However, it's going to take a little bit of time to get through the material. And also, while you're getting through the material, just sort of give yourself a moment to think about when something is appropriate to use, one of the techniques is appropriate to use, and when it's more appropriate to just, go back to basics, or when it's more appropriate to use, say, the mesh current over the super mesh method, or Thevenin's over Norton's, and so forth. But so when you are working these problems as well, it may not be advantageous to memorize a great deal of stuff, with the exception of the definitions for describing circuits. All right, so actually that is it for chapter 4. I've presented all the material that I'm going to present. If it turns out that you need additional clarification for the homework problems or for enacting any of these techniques, let me know and I will create another video. However, at this point, I will wait to hear from you about what you need help with, and we'll move forward from there. The other thing I wanted to let you know is chapter 4 is the second to last chapter that we will have before spring break. And chapter 5 is, I wouldn't say it's easy, but I don't think there are as many disparate yet related items in chapter 5. It's more of a cohesive chapter where we're looking at a particular kind of an amplifier. Kind of interesting, not as all over the place as chapter 4. All right, so please let me know when you have questions or problems, and I'll look forward to hearing from you.